Hi guys, so today I'm gonna do the derivation for the 2 degrees of freedom system. So let's say we have this system. We want to draw the free body diagram and write the equation of motion in matrix form. So you can see that I've write something here. We start with the free body diagram. So if you can remember the steps, first you have to assume the direction of motion. So in this case, it's given to us going upwards is for x1 and x2 are positive going upwards. So they already give you the assumed direction. Oh, there are three type of displacement, yeah? Y, x1 and x2. So no worries. If you understand the steps and understand what it means by relative displacement, so you can actually derive the equation of motion. So now we have actually all these K2, C2 and also K1, C1 both will have the relative displacement. Okay, because they both of them do have are located basically in between two displacements. So you do have relative displacements for both. So we want to see if you have relative displacements means you have to make decision here whether you want to assume tension or whether you want to assume compression. So it's up to you. There's nothing wrong if you assume both tension or both compression, or in my case, I just give an example of what happens if you assume one tension and one compression. Okay, let us see. If I assume tension for C2 and K2, so you can see I've got the arrows upwards as shown in this figure. And for when I assume compression, both C1 and K1 will go inwards like this. So once you've decided of the assumed direction of your for the relative displacements on either tension compression, then you take a look at who gets the positive or negative. Okay, so you can see that this side, okay, both sides of related to x1 basically, so that one you will get negative. This side you will get negative because it's opposite, yeah. And the other side, which is this one, x2 side, you will get same side, so the arrowheads are the same, so you will get positive. Okay, so the way to write the forces, you're gonna see that is gonna be x2 minus x1. Okay, and so we write as K2 x2 minus x1 and C2 x dot 2 minus x dot 1. Then we take a look at for C1 and K1. So for C1 and K1, so the side of x1 is opposite direction. If you look at the arrowhead, it's negative x1. So then that side is negative x1. And the other side of y, you can see towards upwards, so it's same side as y, so that side will get positive. So the way we write it is going to be y minus x1. So you can write the force K1 y minus x1 and C1 y dot minus x dot 1. Okay, so make sure you very clear on the variables that you use according to the questions. Then the next step, if you remember, is basically you want to get the action reactions. So you got all the forces correct. Once you get all the forces correctly with the relative displacements, then only you draw the action reactions as in red color or red arrows there. So I've drawn all the action reactions. So now you just need to write the equation of motion based on M1 and M2. So no worries about You don't have to write for your y, because it's all taken care of from the action reaction. So you just need to write for M1 and M2. Okay, so I've actually copied only all the forces for M1 and M2 here, so that is easier for us to write the equation of motion. So as you can see, for the EOM, you only focus on the masses. So don't worry about and you only write for the action reaction force. So then you write your equation of motion for M1. Here I'm using M2. Okay, so M2 x double dot 2 x2 double dot equals to summation of forces, and you have to follow the direction of your x2. So upwards is positive, so you just take a look at both the red arrows going downwards. That means it's negative. Okay, so for the first m2x double dot 2, you can rearrange, so you can see that both are going downwards. So that's why I have negative here, because opposite of your x2. Okay, so you can rearrange the terms. It will be good if we actually break it out, because after this we're going to collect all the terms of x1 and x2 to put it in the matrix form. Then do the same thing for M1. Here going upwards is positive, so you can see all of the forces are positive, so that's why all the forces here are positive. Alright, then you have to rearrange the terms, and next we put in the matrix form. Okay, so let us take a look at how we convert or write these two equations in terms of matrix. So let us focus first on this first equation. So I have rearranged in terms of all the x double dot and x dot and x here, so we can see it clearly. So since we have the designations of M1, so normally we put x1 first. It will be easier to put all the x1 as the first equation, so we will just focus on this equation first. Yeah, so we have here you can see coefficient of x double dot 1 is only M1, so you just write M1 here. There's nothing in this equation, okay, nothing here that actually has x double dot 2, so that's why you just write 0 for x double dot 2. And for x dot 1, so x dot 1 you have these expressions, okay, c1 plus c2, so I can go ahead and write that one, c1 plus c2. So anything on x dot 2, so we do have here for x dot 2 you have negative c2, so my negative c2 is here. The next one is for coefficient for x1 and x2, so you can see that for x1 is k1 plus k2, so I just write k1 plus k2. Okay, for x2 is only negative k2, so I just put negative k2. Okay, then you have notice that for y, okay, we do have expressions y dot and y here. So you know y is usually input to the system, so we have to leave it on the right hand side of the equation. All the forces are on the left hand side, but input will be on the right hand side of the equation. So we just go ahead and write that in full. So you just have c1y dot plus k1y. Then we go to the next equation, the second equation. So we've done with the first equation. Then we go to the second equation, which represents M2. So the second equation, okay, for the second equation, we take a look at, there's no x double dot 1, but we just have x double dot 2 there, okay. So that's why you have 0 here for x double dot 1, but you do have m2 times x double dot 2. Then take a look at your x dot 1 coefficient. You have negative c2 for your x dot 1. So that would be negative c2. And for x dot 2, okay, you just have x dot 2 here. So it's a positive, so you have that as C2. Then you have your x1. So your x1 coefficient is negative K2. So you have that negative K2. And your last one is x2. You have K2, positive K2. Okay, you don't have any input here, so it's just 0. Alright, so I hope that actually represents all the parameters there. Just coloring up so that maybe you can match up all the variables there. Be easy for you. So I guess so that's the overall of how you go from equation 1, okay, for M1, and equation 2 for M2 in the form of matrix. Okay, so that's all. So we basically done on the derivation of the free body diagram as well as the matrix form. Okay, thank you, bye.